Good morning, everyone. So, today we're going to discuss the characteristics of stars. Let us know first what a star. Star is a great ball of gas which is mostly composed of hydrogen that is converted to a helium through a process of a thermonuclear reaction called fusion. A star is a huge sphere of a very hot glowing gas. Stars are made by a giant cloud of dust and gas. 1 to 2% of the mass of the stars may consist a heavier element. For example to this is the sun. Sun is our solar system star. When the stars are grouped together, we call them constellation. Star is born in the Eagle Nebula. When the star dies, it runs out of the gases to burn. So this illustration shows the life cycle of the star, from nebula to a black hole. So the life cycle of the star is born in a region which has a high density called nebula. So in the protostars, the first cycle in the star, a region of where is condensing matter will begin to heat up and to start to glow, forming a protostar. At this temperature, the nuclear reaction in which hydrogen fuses to form helium can start. By moving on to the main sequence stars, which is the star begins to release energy, stopping it from contracting. And in the next cycle, which is red supergiant, it is when the core is hot enough for the helium to fuse to form a carbon. The outer layer begins to expand, cool, and shine less brightly. The expanding is now called a red supergiant. And in the helium burning supergiant, it is where the helium starts to surround the core by a shell of a cooling, expanding the gas. That is why it is called helium burning supergiant. So in the multiple shell burning supergiant, it is because when the advance of nuclear burning proceeds in the series of nested shell, while in the supernova, it is where the core collapses in less than a second, causing an explosion called supernova. It is which a shock waves blow of, of the outer layer of the stars. So in the neutron star or the black hole, these are some of the core survives in the explosion of supernova. It is becomes a tiny and a very dense star. So there are different characteristics or different types of stars, which is variable, binary, and nova star. In variable star, it is a star whose is brightness as seen from the Earth. The changes in brightness of the star in variables may may be periodic, semi-irregular, or completely irregular. So in binary, it is a star system consisting two stars orbiting around their common barycenter. The system of two or more stars are called multiple star system. And in the nova star, it is the explosion from the surface of the white dwarf star in a binary star system. It is also called a new star. So there are different characteristics of stars which can be classified in the sizes, color, temperature, composition, and brightness of the star. So the characteristics of stars is the sun is an average star, is an example of an average star. It is not hot or cool, it is not large or small. We can also compare the stars by their temperature, sizes, colors, and brightness. So let's go first with their color and temperature. So the color and temperature of the star is when red star are the coolest, while because their temperature ranges in 2000 degrees Celsius, while in the yellow, which is the example is star, it is hotter than the red stars because their temperature ranges in 5000 degrees Celsius, while in the blue, it is the hottest star. It is the hottest star of all. So because the temperature range in 50,000 degrees Celsius. When the temperature is 200 degrees Celsius, the color is red, or 2000 degrees Celsius, the color of the star is red. When it is 50,000 degrees Celsius, it is color blue. So in this column, you can see the different color and temperature of each star. There are also examples and names of the stars. So in a light year is a unit of distance. It's used to measure the distance in space, distance traveled by light. So in light travels about 9 trillion kilometers in 1 year. It is a light minute and a light second. It is related to a light year. So there is another unit to express or to measure the distance in the space, which is called parsec, which is equivalent into 3.26 light years. One light year is equivalent to 6 trillion kilometers, while in one parsec is equivalent to 3.6 light years. So in this column, these are some distance of the star. In Sirius, the distance from its light years is 8.5, while in Vega it is 20.26.5. Antares is 390 light years, and so on. So in the sizes, let's move on in the sizes of the star. You may think that, or you may look, stars may look like the same in size, but they are not. Size of the stars can be varies different in different categories like in dwarf, medium, giant, and supergiant. So in dwarf size, this is the red dwarf size. It can be compared in the size of the continent of Asia. While in the medium size, one of the example of the medium size is our sun. And in the giant size, the diameter in the giant size is 100 times long or 100 times larger than our sun. This is the example of the giant. While in the supergiant, it is 1,000 times larger than our sun. So in the this is also the some of example of the sizes and structure of the stars. This is the Betelgeuse, Antares, Rigel, Aldebaran. So in the brightness of the stars depend upon the distance and its luminosity. Brightness is related to the distance from Earth and the ages of the star. For us to classify the brightness of the star, it is the first magnitude of the stars are the brightness, while the sixth magnitude stars are the weakest. So the magnitude of stars measures brightness, which is apparent magnitude and absolute magnitude. Apparent magnitude is how star appears from the Earth. They can also measure the observed brightness of the star from the object from any point, whereas in absolute they can calculate the brightness of the object as seen from the standard distance. So they can only measure the brightness of the stars by the standard distance, while in apparent they can measure it from any point that we can see in our naked eye. So in this diagram, it shows the luminosity diagram. The diagram shows that the color of the stars and its luminosity. So the range of luminosity from the bottom to top in this diagram is extremely large. So each star in the sky can be placed in a unique area of this diagram. For example, the sun the Sun is a yellow star of a first solar luminosity. That is why you can find it in the center of the diagram. It also falls on the normal star. From the lower to the upper part of this diagram, it is called main sequence. It is where most of the stars fall along the line. So the spectrum or Spectre, spectroscope, it is a device that measures the spectrum of the light. It is used to examine the spectral lines to know what compounds are being absorbed. So, used to measure also the chemical composition of stars by their temperature and direction in relation to the movement of the Earth. So, how can you measure the spectrum of light. So by setting up a spectroscope with a different tube, each gases has a different spectra or light patterns. So it can like Roy so it can measure the wavelength and the frequency of light. Um, you have noticed that stars seem to twinkle. Do you see them twinkle, di ba? Nakikita natin tuwing gabi. Light from the distant star travels to a various layer of the atmosphere with different densities. So, um, astronomers say that stars do not really twinkle. They just appear twinkled when we see them from our surface. So, for example, when the movement of Earth, or we sometimes call it turbulence, in the atmosphere of the Earth, which cause the starlight to get slightly bent as it travels from the distant star through the atmosphere down to us on the ground. So, to our eyes, the star make it seems like it's twinkle, but it is not. It is because of the turbulence or the movement of air that travels from the atmosphere to out to the ground. So, why do you think it is important to learn about the stars? By learning stars, it may help us understand more about our own sun, which is also the star, which is also the closest stars in our planet. We can also learn something that about how they are born and die. This help us to know or understand how our solar systems are formed. So I hope in this lesson and characteristics of stars you are able to get some information and knowledge. Some people believe that stars help us by giving us knowledge of a person's future and also give us a knowledge of direction. So I hope you understand our lesson and have a knowledge about it. Thank you and have a great day. So I will see you in our next meeting.